Hello, guys and gals, me Mutahar, and welcome to another Virus Investigations, ladies and gentlemen. Now, if I got a big smile on my face, it's because I have infected myself with a little Linux bootkit malware. Now, you might be like, whoa, what does that mean, Muta? First off, I'm a Linux user. Much like vegans, Linux users have to basically announce to everyone that they do in fact use Linux as an operating system. Now, Linux is a pretty unused operating system, especially compared to, let's say, something like Windows, but it's slowly growing. And when something grows in market share, it starts to attract actual hackers, writing little pieces of malware to infect anybody using this device. So obviously, as a Linux user, something that I want to talk about today are bootkits. Now, bootkits are a special type of malware, okay? They are actual pieces of malware that reside in your boot folders. So every time you fire up your computer, there's something known as a basic input-output system, right? A BIOS. So when you build a computer and you hit power for the first time, your computer will fire up your BIOS on the motherboard and effectively post the system to make sure everything is alive. Once the BIOS can confirm that, oh my god, we are actually a functioning system. And once it detects the bootloaders then start the initialization processes and get you loaded up into Windows. Now, all of this happens within like a minute for most computers, but that's generally the idea. Now, since, I believe, 2006, the BIOSes of original days moved on to something known as UEFI, okay, UEFI, which are much more modern versions of BIOSes. But ultimately, all of this is just technical jargon, because realistically, we're talking about that boot process. So when a motherboard fires up and looks through what is known as an EFI partition for most modern operating systems like Windows 11, even Windows 10, something like most modern Linux distributions, it's that folder that contains malware. Now, the problem with a bootkit malware is it is one of the most dangerous pieces of viruses, because if something is loading up alongside your computer's boot process and escalates its privileges, we're talking about a virus that is, in some cases, almost undetectable depending on how it's stored, and one that will persist and have the highest level of access to your computer. And anytime a virus gets high-level access, you can imagine some high-level damage. So today, we're going to show you kind of how this works. Now here I've got a little VM, a virtual machine, and inside here I've got a special virus known as Black Lotus. Now Black Lotus is a bootkit, and of course you can see it's just a simple small file. Now if I double click on this file, it just launches and nothing happens. So after a quick reboot, my computer looks to be the exact same. I've got 40 gigs left on my C drive, my floppy disk is inaccessible, and I've got nothing in the DVD. But my computer is now hacked with a very dangerous bootkit, okay? So how do we verify this? Well, like I said earlier, we gotta look at that EFI partition and see what happened to our little boot files. So inside a little terminal that I opened up, ladies and gentlemen, I typed in the words mount volume E, so that is the EFI drive. Now you don't see it anywhere in my computer, but this little tiny drive, around 200 megabytes in size, contains all of the boot information Microsoft uses to load up the Windows system. Now, if you've been successfully hit, it won't be flashy like some malwares, but what you'll see is, for instance, in your EFI partition, when you're at EFI Microsoft boot, if you're looking carefully, there are three files you got to pay attention to: winload.efi, grubx64, and bootmgfw, right? So if you notice on the left, the modification times based on this Microsoft provided sample, they basically showed that the times don't exactly line up with each other, which is not, wild, but it is a sign of suspicion. Now, another big attack point, another big reveal is underneath the registry for Windows when you go to Hypervisor Enforced Code Integrity, which is a system designed to prevent your system from loading unsigned kernel code. That will be modified to 0, okay? And of course, beyond all of it, even your Windows Defender, which is a built-in antivirus feature, that will encounter an error and will be disabled as a second security feature for this malware. And then after that, it'll start communicating to command servers around the world. So at this moment, you have been infected with a pretty dangerous virus that is basically loading up at the earliest stages of your computer. And that's never okay. My computer is now infected, and while nothing really seems crazy and out of the norm, this is a bootkit virus. And once you get a bootkit virus, you really do have to reinstall not just your operating system, but you really have to flush out all of your boot directories to go. Okay, it's fucked up. My computer is infected. Now, thankfully, I have a virtual machine where even the network that this VM is connected to is isolated and sandboxed. Remember, I am a professional idiot doing this. Do not attempt or run any of these programs on your home computer. Even in a VM, just be very careful. Let the dumbass like me do it for you on a YouTube video. So why am I talking about a Windows malware? Muda, you don't even use Windows. You're a Linux user. Well, ladies and gentlemen, a virus known as BootKitty, get it? BootKitty, showed up for Linux users a couple weeks ago. And this kind of threw the entire community in for a little bit of a tizzy. But I'm here to demystify a lot of this and kind of, again, kill some of the fear-mongering that's been going on. Yes, it's true I installed a dangerous Linux virus on one of my virtualized systems, but I'm going to show you how it's probably one situation where if you were to go down this road, you'd have to make some serious mistakes that are very easily avoidable. So when I looked at this actual situation from Ars Technica, a pretty respectable page, found on VirusTotal. It initially, I believe, said found in the wild, but I don't have that right off the bat. I'm sure I can dig it up through the Wayback Machine. The world's first UEFI bootkit for Linux. So immediately they had to issue a retraction because the way they made this sound, it was apparently something that was unkillable, quote unquote. Now, there is no virus that is unkillable on some ordinary gamers, okay? If we find a computer virus, you bet there's a way to reverse or at least mitigate the damage as much as you can and at least get rid of it, okay? Never throw a perfectly good computer out because you got a fucking virus, okay? Now, I don't want to blame Ars Technica entirely. I think it's definitely a misreport on their end, but at the end of the day, this is a confusing terminology, and I'm sure Clickbait probably got the better idea for some of the people here. But because it's confusing, it's best to demystify and explain that when it comes to a bootkit, and since these files reside on your actual boot directory, you can effectively overwrite with them with clean files or just completely reinstall your OS and do everything from scratch, which will get rid of the virus. It's not unkillable, it was just misreported. So immediately I went to VirusTotal to look up this virus, and one that I found, which was 95 kilobytes, this is the actual virus in question, BootKitty. Now, as you can see, it's tripped up a whole lot of antivirus engines. 44 out of 70 security vendors actually ended up flagging it. And BootKitty was known to the entire world. So I ended up getting the actual sample itself, running it on a system, and basically I did in fact infect, or at least use this proof of concept under my system. So ESET Research, some of the people talking about this, actually said that one of the students ended up actually contacting them and talking about this. So apparently in Korea, there was a few cybersecurity students in the Best of the Best training program where they said the primary aim of this project is to raise awareness within the security community about potential risks and to encourage proactive measures to prevent similar threats. Unfortunately, few bootkit samples were disclosed prior to the planned conference presentation. So this is something where people are making these as proof of concept, and so far as anybody's knowledge is, nobody has been infected with this so far, except this guy right here and anybody who was researching this, quote unquote. So initially when people were looking into this, there was an entire Discord centered around, again, this one Linux kernel rootkit discovered by Humzok711. And this was known as IranuKit, which again was a modular Linux kernel rootkit. So one of the things that showed up in the research Discord and the people sharing files around was one interesting file known as logofail.bmp. Now what Logofail is, ladies and gentlemen, is an exploit used by the actual hackers in the situation to leverage BootKitty. So, you know, every time you fire up your computer and you see like your motherboard manufacturer logo, sometimes you see ASUS, you'll see like, you know, whatever your motherboard is, right? It could be like Gigabyte, it could be whatever. That like initial logo, that picture of your motherboard company as you fire up your computer, and underneath it will be like press delete or F1 to go into the BIOS setup. That image is actually processed by something known as an image parser. And there's a pretty great write-up for Logofail. There's a 53-page slide if you ever want to actually get into it. But generally the idea is these logos would basically be where the vulnerabilities were hidden inside the system's firmware. So for the moment the server was active, the people who were researching it went down and found logofail.bmp and logofail.fake. Now immediately when you're looking at the fake, it's like 7.7 kilobytes in size. But this one, Logofail BMP, was around 16 megabytes. So people downloaded it and started looking closer into the actual hexadecimal data for this. And inside the data came out 4 key findings. For instance, one of them being 00FDFFFF00000000. And this would be the width and the height of that BMP file. Then, of course, this big chunk over here with repeated code like FFFF000200, then FF000200FF000200FF. That would be a pretty repeated pattern. Then right underneath it was what appeared to be shellcode at the end of the image. So you can see right over here, this is apparently shellcode written in right here. And then, of course, towards the tail end of the bottom, you started to see a string which served as metadata or a certificate. So you started to see things like IranoKit and BootKitty in that, logofail.bmp. Now inside the malware, when looking at BootKitty's actual software, obviously if we right click and go to its properties, you can actually see that it's got a little digital signature. So the name of the signer is SEO, SHA-256 is the digest algorithm, and of course if you hit the details, you can go to advanced and find out that, oh my god, this is in fact BootKitty. So you can start to see that the issuer is SEO, BootKitty, 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 IranoKit, and KR, which I assume is for Korea. Now this is of course using a custom signature, which means that it's already beatable if you have something like Secure Boot functioning and updated and working on your system. Now for those people that don't have things like Secure Boot, you're kind of fucked. So on infected machines, they would see this logo being replaced by the actual BootKit malware itself. So if you see this logo, you are, again, as you can imagine, pretty fucked. Now in this situation, there's 2 mitigations right to this stuff. First off, if you have things like Secure Boot enabled, you will most definitely be fine, and this malware shouldn't necessarily be able to mitigate you as long as you've got things like that enabled. The other reality is as long as you have patches for the Logofail vulnerability for your motherboard, you should also be fine. And there's plenty of actual manufacturers that through the course of 2024, and even as early as I think 2023, or at least the tail end of it, there were actually a bunch of manufacturers that came in with patches. So for instance, if you're like Lenovo, for instance, they actually did cover it, the BIOS image parsing function vulnerabilities, like they took care of Logofail right over here. But again, even beyond all of it, there were AMD motherboard partners that also started rolling out those various BIOS updates. But the thing about this is you obviously need to have these situations enabled. And for Linux users, all right, if you're dealing on something like Arch Linux because you think it's cool and you haven't really went into the complete meat and bones of securing your system, you may not have things like Secure Boot enabled. You may not want to enable it because you don't think you need it. And of course, even beyond all of that, some people that I know have owned entire gaming computers and have never once updated the BIOS on their motherboard. And it's something that even I'm guilty of. It's one of those things that people often forget. So if you're not updating everything in your chain, you are opening yourself up to a vulnerability like BootKitty or like Logofail. Now to go back to BootKitty and the actual malware, remember that it actually has its own self-signed certificate. Which means immediately off the bat, if you have UEFI Secure Boot enabled by default, you should, in theory, be completely fine. And this will not allow you to actually run this because it's not actually cryptographically signed by something that the system will know. So according to a good write-up by WeLive Security, again, ESET, they basically said that once BootKitty is executed by the shim, it checks to see whether UEFI Secure Boot is enabled by examining the value of Secure Boot's UEFI variable. So then it hooks 2 functions, and one of them is EFI Security to Arch Protocol, and this is used by the firmware to measure and verify the integrity of UEFI PE images. So then the next one is EFI Security Arch Protocol File Authentication State. And that is used by the firmware to execute a platform-specific policy in response to different authentication status values. So again, it hooks it in a way where it always returns something known as EFI success, meaning that the firmware can use the file regardless of whatever the authentication state actually is. Now again, what really makes this dangerous is that obviously it is hooking into the EFI partition. Now remember at the beginning of the video, the EFI partition is designed to serve as sort of the boot folder or where the bootloader is located. So when you fire up Linux, it's typically going to start up what is known as an init process, which is the first process underneath Linux. And through that, all the child and zombie processes basically come out. So init, again, being the program that starts the initial process, the first boot of Linux, and passes on to other system like, daemons and whatnot down the road. So once you boot up BootKitty, for instance, that, actual kernel that you have is marked as potentially tainted. Actually, it is just tainted right there. Okay, so I know that I have kind of thrown a lot of technical shit at you, but the reality of it is that this is a pretty dangerous virus, right? Obviously, any form of a bootkit is dangerous on your system. If you have any virus that loads up in your system's initial init process, or just starts off at a high privilege, at a high escalated tier, then the amount of damage it can do, not just to steal your personal information, but potentially spread around and remain persistent on your system is astronomically high. And it's one of those things where you can actually mitigate it pretty easily. Now, I've installed this for testing purposes, but the reality of it is most users will not ever have to worry about it, because in order to get this thing working, in order to get it running, you really do have to be at your computer and basically make the stars effectively align to cause this malware to occur. But there's a couple ways you can actually make yourself effectively safe in this situation. So when I was talking about Ars Technica's article earlier, and they kind of said it was unkillable, because this is a bootloader malware, you can get rid of it simply by reinstalling your bootloader. Or if you wanted to completely nuke your fucking computer, you can reinstall your entire operating system. So the thing about bootkit stuff is obviously this malware exists on Windows, and it has existed on Windows for a long time. But Microsoft is not the only one where this occurs. Obviously, we just saw this happen underneath Linux. And Mac users, they could also have things like bootkits. But a lot of modern computers use things like UEFI Secure Boot. Now, UEFI Secure Boot is not a Microsoft exclusive thing. It is a pretty open part of the UEFI standard, and effectively what it does, just for lack of a better term, is that it basically ensures that your computer loads up signed binaries, and anything that it doesn't recognize as signed or part of the actual boot chain, it will completely ignore. It will not allow anything unrecognized to run on your system. So it will prevent the loading of specific drivers or certain bootloaders that just do not have that acceptable digital signature. So for something like BootKitty that was coming self-signed, it's not going to get past a basic UEFI secure boot security check. So you will be fine in that regard. And even if you had BootKitty sitting on your system and it was, assaulting your computer's security, then simply by reinstalling your bootloader, or again, most people can reinstall their operating system, you should effectively be fine. Now, most modern operating systems come with Secure Boot pretty much enabled, right? If you install modern Windows operating systems, the way that it installs your Windows is if you have Secure Boot running on your motherboard, which most people buying a new computer probably do. If you bought a computer as a pre-built or something from a store, it most likely had Secure Boot running on it by default. And in that situation, Windows has basically configured everything to just work out of the box. Now, if you have something like Linux, there are certain distributions. I think Ubuntu does it. I think Linux Mint does this by default, where Secure Boot, as long as you have it enabled, should just work. But let's say that you're on Arch Linux or you're on like a special version of Linux where Secure Boot isn't a thing. This is where you have to actually enable it so you can get that extra level of security so that any of these kind of weird bits and blobs that shouldn't exist on your system don't have a chance of running. Maybe this is probably where I should redo an Arch Linux installation video sometime next month or whenever I get the time, so that I can show you how to encrypt your drives, ensure things like Secure Boot work, because I think having that level of security is very important. Look, just because people use Linux doesn't make your device any safer. As Linux grows in its popularity and its market share, people are going to be developing malware. This was just a proof of concept. Next year, there could actually be serious malware that targets Linux, especially as more people buy Steam Decks. Valve makes SteamOS basically a standard for handheld systems, and some people start using it on their laptops, their gaming computers, and some vendors around the world might even start pushing Linux instead of Windows. As this ecosystem grows, people are going to target it. So it's better that you start to implement these security features. Things like UEFI Secure Boot, TPM 2.0, these security requirements have been around for a long time. And honestly, if you have any modern hardware, you have these features in your system. So it's best you have these basic things enabled just out of extra security for your system. Again, more security is no harm, no foul, okay? These systems, when they work, and they do work, when they're enabled and functioning, you will not notice them, but the security they provide you is absolutely paramount. So what we've learned today, ladies and gentlemen, again, for the final rundown, is in order to bypass this, just have an updated system and make sure UEFI Secure Boot is just functioning regardless of what operating system you have on your computer. Remember, Windows is not the only unsafe operating system. If it's anything you can learn from this video is no system is truly safe if you just manage to ignore security. Linux might be safer in some ways by design, but now that more people are beginning to target it, it's better that you start to use the same security principles and standards you use on Windows as you do on Linux. And at the end of the day, when it comes to certain programs that could possibly open you up to BootKitty, this is where you have to apply common fucking sense, okay? Do not just download random shit and binaries off of the internet, okay? Download your programs from trusted vendors. Download all your applications from trusted locations. Do not run random shit you download on your computer unless you know exactly what you're doing. And then you never really have to worry about shit like BootKitty, as long as you're at least decently paranoid about the internet. But ladies and gentlemen, security and computers and malware require an ever-vigilant presence and mind and protection from all sorts of threats. So hopefully you learned something today. Hopefully you got a kick out of me infecting myself with a dangerous virus. And of course, I will kill every single virtual machine you saw in today's video on Some Ordinary Gamers, ensuring that all these viruses stay in the fucking recycle bin where they belong. And once they go to the recycle bin, I shred the ever-loving shit out of them. Ladies and gentlemen, if you like what you saw, please like, comment, and subscribe. Dislike it if you dislike it. I am out.